Hey guys, welcome today. I'm sorry that I couldn't be here today, but I will continue on by teaching you guys. So in lesson 8.3 is kind of where we left off last on Wednesday. And what we've done was talked about what the true proportion of when a Hershey Kiss will land when you toss it up. So the first thing we did was kind of talk about the three conditions that needs to be met before we do a test. So the three conditions was making sure things are random, independent, as well as normal. And then we moved on to finding critical values. So these critical values will help when we are looking for our margin of error. So notice that in our first few problems, we got a standard deviation of 1.28 for 80%. For 90%, we got 1.645. And I made a little error when I told you guys what to plug into your calculators. So just make sure you calculate one of the tail ends, and that's what you're going to put for area for those that have these calculators over here. So area is going to be just one of the tail ends. So like for example, for the first one was 0.10. So the area should be 0.10. Area for the second one is 0.05. And then moving down, these are the values that you should be inputting into your calculators. And in terms of the final answer for here, the values that you should get is going to be 1.960. So which notice that 95% of our data is 2 standard deviation. This one is 1.96. So this is a little bit more accurate than 2, but that's an approximated answer. And for the 99, we have 2.576. And that's approximate as well. These values will vary just because sometimes if you're using a calculator or sometimes you're using table A, it'll be off a few digits, but it's totally fine as long as you get pretty close, then you know you're okay. Okay, so moving forward is part 8 where it says to calculate your margin of error for a 95% interval by multiplying the critical value and the standard deviation you found and show your work. So what I'm going to do here is just label some things. For example, critical value is notated as Z star, and then standard deviation from above was the standard deviation of P hat, or we can also call it our standard error of P hat. So either or, whatever way you like seeing it. And then we're just going to take these two values and then multiply them together. So maybe I should put this. Okay, so our margin of error for our 95% confidence interval, we're going to go back and take a look, and this is the value that we have here. So I'm going to put 1.960. So I'm just going to keep it in the positive format. Either way is going to work because in the end we'll definitely have like a plus or minus, but we're going to multiply that by our previous value. So I'm going to go to the previous slide. And this is our previous value for our standard deviation. So plugging that in, which was 0.0698, and when you calculate that out, that should give me a final answer of 0.137. So this is approximately 14% on the left side or in the right side of our point estimator, okay? Okay, so now that we found our margin of error, that just makes it 10 times easier to find our confidence interval. So when we talk about our confidence interval, we always talk about the point estimator first. That will represent the middle, and our margin of error will be added to the left and to the right, and that's why you see the whole plus or minus here. So our point estimator will come from the previous slide as well. And notice this is our point estimator 0.42. So I'm going to write that down. 0.42, and then plus or minus 0.137. So that's how I get from, let's say, my pieces of my equation to what's going to eventually become my confidence interval. So from here, all you're doing is just taking 0.42 and subtracting 0.137. And then you're also going to add 0.137. So my final answer here is going to be 0.283 and then comma 0.557. Okay, so this is what I'm estimating for the probability of my Hershey Kisses landing um, on the flat end. So in general, so this is supposed to be generalized to the whole entire population. So this is kind of a pretty good chance. Like if you're just tossing it up, it can reach all the way to 50% landing on the table nicely. Okay. And then the very last question for today, it says within this sketch. So this is a totally random sketch. Like let's just assume that we took everyone's data or a few kids' data and then we put it into this graph. So what do you think the true proportion of kisses that land flat is? So these are 95% confidence interval. And if we think back to what confidence intervals and confidence levels are, so if I had a confidence level of 95%, I want at least 95% of my intervals hitting whatever the true proportion is. So let's just see that. Notice that we have 1, 2, 3, 4, 5, 6 of these intervals in general. So let's just say 6 times 0.95. And then if I were to multiply that out, that gave me 5.7. So I at least want, let's just say 5 intervals to hit. So which one is going to be the odd one out? So either maybe there's multiple possibilities because I can do something like this. So like maybe I want this value to be my true proportion because notice that this line right here kind of gets taken out. So that's 5 out of 6. Maybe I want to do something like this where notice that I hit all the lines and then this one is the odd man out. So I guess this is at what you think at this point because we're not too sure yet. So I'll just stick with this one. So maybe the true proportion. So whenever I denote true proportion is always my p-value. And I'll say p equals 0.42. And notice that if I look at 0.42, it is captured within my interval itself. So this is a good guess. If I did the other way around, 0.35, that was also captured in my interval. So this I would say is a pretty decent guess. Okay, so what we've done today, or have done in the past 2 days, is talk about the conditions that needs to be met. We also talked about critical values that will stay consistent as we move on and use more of these critical values. So 1.645, 1.96, 2.576, you will continuously use these numbers. So these numbers maybe you should just end up memorizing. And then the formula to find our confidence interval for proportions, because we're going to do proportions and then we're going to do means, is our point estimator plus our margin of error. And notice that our margin of error is calculated by finding our confidence our confidence levels critical value. So it's all different for each one. And then multiplying that by our standard error of our proportion as well. So the check your understanding is going to be due Monday or Tuesday, depending on when I see you at 11:59. So I suggest that you look over the next lesson before you do the check for understanding for this, and then I will do the next lesson right now. Hey guys, this is lesson 8.3b, how much of the earth is covered by water. So we are going to investigate this idea, and some of you guys might already know the true proportion, which is very similar to the amount of water that we have in our body. So just to move on, it says what proportion of the earth is covered by water? We will investigate this question by taking a random sample of locations on the globe, which you guys have done already on Wednesday. So we're going to go back to that sheet so that we can take our data and then input it into the notes for today. So part 1 is just to calculate the proportions of the location from your sample that are water. So our p hat is going to equal to, and let me head over to the sheet right now. So I'm taking somebody's sheet, and then this is what it should look like. You guys should have all filled it out already. And then what I'm focusing in on is just the tallies that are at the bottom right-hand corner. And notice that the total amount of locations that are water are 33 at a total count of 50. So that's what I'm inputting into my notes. I have 33 out of 50, and I know I could double it to get my percentage, which is 0.66. So I'm getting an approximate answer of 0.66 as the amount of water that is covered on Earth. So part 2 is to construct a 95% confidence interval to estimate the true proportion of the Earth that is water. So here what we're going to actually do is start doing a test to basically show our readers what we can find out from our samples and what we can use, that we can use our samples to estimate what's really going on. And here we're going to show them a confidence interval basically. Okay, so in our test in general, we actually have 4 steps that we need to cover to make it to make our test valid and comprehensive enough. So the first thing that we're going to do is something called to state. So this just represents that we're going to state the parameters that we want to estimate and then show our confidence level as well. Secondly, we are going to plan and we're going to basically identify the appropriate inference method and check conditions. So we're going to tell our readers what kind of test we are doing and what are the conditions that need to be met within the test. And then we are going to show our readers all our calculations as well. And then lastly, we're going to conclude because we got to let our readers know what we found out and what we guess for our actual population or our actual proportion to be. And then I will tell you what the true proportion is at the very end. All right, so first thing we're going to do is that we know our confidence level. Our confidence level is at 95%, which is what they told us to kind of look at. In terms of our parameter, the parameter that we are looking for is the p-value, which is going to represent the true proportion of Earth that is covered by water. Okay, secondly is to plan. So we got to make sure that we have everything that we need, like let's say the supplies that we need to back our information up. So first thing is the name of our procedure. So the name of our procedure here is going to change depending on if it's proportions or if it's means, if it's one proportion or if it's two proportions. So here we're just looking at water. We're not looking at land and water. So we only have one proportion instead of two. And notice that we only have one point estimator. So that's another way that you can take a look at that. So this is called one sample, Z interval, and then 4 proportions. Or you can just put P, okay? So one sample, Z, we're using Z scores here, and then the interval because we're looking at confidence interval, and then proportions, obviously. All right, so the 3 conditions that we need to check is the next thing we need to do is 1, to see if our samples are random. And then yes, it is because we basically used a simple random sample to find our 50. And in our method, we just use a simple random sample. Okay. Next is the 10% condition. So we know that we sampled 50 locations, and on Earth, there are so many locations in general. But here we're going to put all locations on Earth. And then we know this is met, so I'm going to put a check mark to indicate that that is met. So that tells me that this is independent. And then lastly, I have to do large counts. So my sample size is 50. I'm going to multiply that by 0.66, and that should give me a value that is larger than 10. So let me calculate that out, which is 33. And I know that is greater than or equal to 10. And I also have to check the other one, which is n times or 50 times 0.34. I'm going to calculate that, which is going to give me 17, which we also know is greater than or equal to 10. So we know that that works. So our 3 conditions were all met. Okay, and then we have the do part, which is super crucial. So if these conditions are met, then we're able to perform our calculation. We know it's normal, so then we know we can use these scores. So the first thing we need to do in order to create a confidence interval is just to generalize what the formula is. So in general, the formula is the point estimator plus or minus our margin of error. And if I were to use notations to denote this, This is p hat plus or minus our critical value times our standard deviation. So which is p hat times 1 minus p hat all over n. Okay, so all this from just the previous, so hopefully nothing is new. And then plugging in numbers into the formula. So our p hat value was taken from above, which is 0.66, plus or minus our z star. So what is our critical value, but which critical value are we looking at? So notice our confidence level is 95%. And then I'm going to go back and look for, and notice that it is in here. My confidence level for 95% is 1.96. I'm going to use that value. You can go straight to your calculator if you don't memorize these, but remember in your calculator, you are doing inverse norm, but you're doing 0.025, okay? And then try to remember why I did 0.025. Okay, so 1.96, and then just plug in all the individual values here. If you want to subtract 1, you can just leave it like that if you want to. And then there we go. Okay, so I could calculate this all in the calculator, but I technically don't need to because my calculator has some functions that I can just plug in some values and I can get my answer. So my final answer in general should be in a confidence interval type form, okay? So I need 2 values here, and one value is going to be from 0.66 plus my margin of error, and then 0.66 minus my margin of error. So in general, these are the calculations in terms of your calculator and how to find the confidence interval. So you're going to go to stats and you're going to move over to test, and you're going to go all the way down till you see 1 prop z interval. So notice that 1 represents 1 sample, prop represents proportions, and then we're doing z intervals. And these are the things that you're going to plug into the calculator. So your calculator is going to pop up with a few values. So X, you're going to put in the number of water locations. So you're going to put in the number 33. Here is sample size. So I'm going to put 50. And then my confidence level is 0.95 for this situation. And then I'm going to calculate. So I'm going to show you guys that in the calculator so you can see what we get. Okay, so stats, moving over to test, and then 1 prop z interval. So notice there's 2 things. There's 1 prop z test, which is number 5 for me. And then if you go all the way down to A, it's 1 prop z interval. That's what you want. Okay, so in 1 prop z interval, notice that I have to put in an x value. So the x value that I should put in there is 33. For n, I should put 50. And then confidence level, you should change it. Mine's already set to 95, and then I'm going to calculate. So notice that my p hat pops up here. So if my p hat is incorrect, then you know you put your numbers in incorrect from before. So some of you guys will actually get an interval. My calculator is just showing my lower interval, or the lower end of my interval and the upper end of my interval. So those are the values that I'm going to take and then put it into my equation, or my answers. Okay, so going back, so here it is again. If you need to pause, pause. All right, so my numbers are 0.5287 and then 0.7913. Okay, so as you guys are looking at that interval, maybe you guys can already notice that this margin of error is really large, because some of you guys already know what the true proportion or can estimate what the true proportion is, but it is what it is if we want to be 95% confident. Okay, so in terms of our last portion to do is we need to conclude our test. So we are going to interpret our interval in context of the problem. And here I set up kind of like a layout already. So we are blank percent confident that the true proportion of the earth covered by water is captured in the interval blank. So all this is easy to fill out. The only thing that you have to make sure that you guys end up doing is to write this in context. So notice that I put true proportion of earth covered by water. That's ideally what I'm looking for. I'm trying to find the truth. So we are 95% confident that the true proportion of Earth covered by water is captured in the interval 0.5287 up to 0.7913. So we are going to hope and hopefully that our test is not biased, that the amount of water or the percent of water covered that covers the earth is in here. So the true proportion is actually, so P is actually 0.71. And notice that 0.71 is captured in our claim. So this is basically called our claim. And so our claim here is valid and people would probably support us versus deny us. Okay. All right. So that's pretty much it for our lesson. So let me just kind of go over what we have done. So important ideas is there's a 4-step process in order to test what's going on, and just making sure that you kind of give a thorough report to your readers in order to kind of prove some claim. So first step is to state. So state what you're doing. To plan is make sure that you have all your materials that are needed for your test. And then part C is to do, and do just means that do all your calculations, put in your work, and then 4 is to conclude what you have done and state that you are, and basically interpret everything that you've done. And then number 2, in terms of the important ideas, is something you're going to do in the check your understanding, but what it is choosing the correct sample size. So in order to choose a correct sample size, sometimes they'll give you like a equation and they'll tell you to find the sample size that is associated with that equation. So what you want to do is take your margin of error, and take the formula for that and plug in everything you may possibly know about that equation, move things around to get n by itself. So that's one thing that you can do. Something else that you guys need to know is that whenever p hat is unknown and whenever p and p hat is unknown, something that you can always use is 0.5, which is 50%, and 50% usually things always is like this or that, so it's binary. So 0.5 is going to be your conservative calculation. And then lastly, in terms of also your margin of error and sample size and stuff, so if your sample size is a decimal number, then you always round up just to make sure that you account for somebody. You always want to account for that person versus not account for them, which is also biased, so always round up. Okay, so your check your understanding is due on Monday as well. And then I am also going to post the check your understanding for lesson 8.1. So just make sure you look over that and see if you're doing everything correctly, because on the FRQ, that is the style I want you guys to write it in. Okay, so hopefully this is comprehensive. If you have any questions, please email me and make sure that you guys have submitted your attendance for today. And that should be in a Google form. Bye.